Hello guys, welcome to Machine Learning in Second Study Group. I would like to give you a quick introduction of how this group will work. So basically it's 4 weeks long course. The first week we will be doing simple Hello XOR problem, then we will work on University of Neural Network, then we will work on generalization, and the last week will be neural network structure optimization. So basic rule of study group: you need to spend 6 hours per week. You need to spend 2 hours before Wednesday, Friday, Sunday. The first task would be Hello XOR. Deadline for the first task you can see here, and this is the link for the problem. I will show you how to work with it a little bit later. After every 2 hours you would need to fill out report. This report is needed that other people in the group can see what they missed in their self-study, so that we can study more efficiently. There is only 5 questions. One is question: what progress did you make in 2 hours? Then this is really critical question: techniques used in solution and how well they work. Often it will be the case that some techniques that you read and find out, you try to apply it, and for some reason they did not work. And then you can think that maybe this will not work at all for this problem, but then you will see that other guy was able to use it successfully, and then I probably made a mistake, and you will try to find it. Same question, challenges, same motivation for this question, like whether maybe it will help you to see how somebody overcome challenge, and you will do the same. One question for mentor is just to keep discussion going, and this question is share one link. You basically need to share something that you find very useful for your understanding of machine learning. And there's examples, so please fill out reports. The better you fill out reports, the better it will be for group and for you. So let's go to set up instructions. There's 3 ways you can set up your environment. One is to use Google Colab. This is easiest way, and I will demo this way. Then another way would be to use Docker. And you can install it locally. This option if your internet is not as good. And the third option is like you install it by yourself, and then you don't ask me what's wrong, because I don't want to go this way. Okay, so let's go to the problem. So this is a link to the problem. If we will click on it, we will go to this simple interface. You need to log in with Facebook. You can watch this 1-minute video with motivation for what we are doing here. Once you log in, you will see the interface for the problems. There's like a lot of different problems. For the first week we work with Hello XOR problem. So the first link here is problem. It would be the problem description. If you click here, you will see the description for Hello XOR, but it's basically nothing special. But of course we can click and see it. So basically what we see here is description. What is XOR function? It's just simple function: 0 0 go to 0, 0 1 1 0 go to 1, and 1 1 go to 0. Here you also can see the instruction if you decided to install everything locally, how to install Docker and all that stuff that you can have fun with. Okay, let's close this up and let's go back. Okay, we lost it. Let's open it one more time. Okay, so this is a problem description here. Data provider is the code that generate basically test data for your machine learning problem. So let's close it, and then there's editor where there's already template with the way it's work, and it's look a lot of stuff that is different, but you get used to it. This template is really good. Then you will be able to submit your solution, but this interface is used only when you have solution and you want to like check that it's like you did not cheat and everything worked properly. But if you working on like exploring what to do, then usually you click this blue button, download problem in notebook, and once you download it, you go to Google Colab, and it will generate, you upload it, and it will be this like 3 sections. First section is just code base that you probably never need to read. Then there's problem description, basically is JSON files with description of the test, and then this code that we already see for data generation. You probably never would need to open this too. And here's the solution template. So the solution template is pretty straightforward, but let me quickly explain it to you. Basically, it would be a neural network model. We use PyTorch for this. Then there's class solution with only one method train model, which basically responsible for training the model. And it's look a lot of stuff here. Let's click runtime, run all, and see what's happened here. While it's running, let's see what we have here. Solution train model. The other method is for printing some statistics, and after this line we see that this is the code that will not be run on a server but run here on Colab locally. So it basically tests your solution, so it's tester. So there's two mode you can run. You can run a tester that it will be testing the same way as it will be tested on server, and then there's a grid search. Grid search is needed when you want to try different experimental parameters, and you will get to it and how it's useful. So as we see, the result is, so right now we see that the neural network was running trying to learn for 5,000 steps. It's run for almost 2 seconds and it basically didn't run anything, but there's few hints that will help you working basically. Then after that we see some output. This output is already from grid search. It's basically trying do same stuff but with different parameters, and it's a lot of outputs. First thing that I would recommend you to do to like clean up all these hints, once you understand them, just like remove that line so you would not see it. And after each completed line, you will see some statistics in table format. It basically shows you what would be oh, it's strange, but okay, what would be minimum mean and max value for number of steps for network to learn with, like for example with hidden size 3 and learning rate 1, it would need in average 365 steps. And if for another metric is time left, so usually we have for the task 2 seconds, so everything that left from this 2 seconds, for example with for hidden size, okay, let's do this, for hidden size and learning rate 2, in average it's number 10, we will get like 1 second and 9.9 left, so it's basically less than 0.1 seconds for these parameters. And here is also different way to represent the data. In this graph we see that so we see learning rate and value is time left. So time left for different learning rates with hidden size 4. The blue line represents the average and blue range represent the confidence range. Okay, you will need to work and try to understand all this stuff. If it's like, oh my god, there's so many different stuff. Then you need to go back a little bit. Okay, and in the end of this post it say, like, if you have no idea what's going on, you need to open like tutorial tasks. And tutorial task is just if you open it, it just simple link to Google Colab notebook, which, let me open it, this one, which basically show you like step-by-step introduction from like really simple stuff to neural networks of same stuff, run all. We start with like describing what is PyTorch, what is Tensor, and how Tensor is different from array. It's basically some meta array. Then there's description what is derivative, what is gradient, and there's some visualization. If you don't know what is derivative, you can play with it and see how the derivative is just like this cool line that it touches your function. Then there's video introduction to neural network and gradient descent by a really nice guy. I don't know his name, but okay. Then there's some utilities needed for visualization, and then we do gradient descent with like, first we do with really simple stuff here, which is like really easy to read, and it's usually the same example, and of course you can play with it as well with different parameters, and you will see how it's changed, all that stuff. And then we start to do some abstractions. First of all, we in the first case we was calculating derivative by hand, and then we start calculating using PyTorch. In this example, same example, but like framework a little bit changes. Then we introduce model and all that stuff, and oops, there's some problems, I don't know why. Unfair. Let me see if we can, function is not defined. Okay, function is not defined, probably because it's not defined here, sadly. Let's try to change it. Okay, it's working. Probably it's so same stuff, but like some more level of abstractions, and then more level of abstraction, and I guess there's same error here. Yeah, and unfortunately same problem, that function is not defined. And then even more abstraction, and in the end we end with example that is pretty look like the template that we have. So it has model, it has solution. So that's it. I hope you find this video helpful, and once you find like good parameters, so let's go back and quickly try to, so once you see this hint like increase hidden size, you say okay 3, and then learning rate is too small, increase learning rate, and you run it, and you will see that it start passing. So once you have it, you copy the code, and of course like it's passed, but like with average number of steps is like 300 whatever. Let me quickly disable grid search, so false. 300 something, and you need, your task for first week is to optimize it that it would be able to run in less than 10 steps. And once you have it, you just copy code, you go back to this problem, you put your code here, and you submit, it will run and it will evaluate, accept it, and once it's finished running, you would be able to see you in the ranking, and you will see how other people do. That's it. Happy study.